GIGABYTE AI Top Utility is the software designed to fine-tune pre-trained LLMs. It allows you to set up tasks quickly with no coding required. Here is some important information you should know before we get started. First, your computer needs an AI Top certified motherboard, graphics card, and SSD for best performance. Next, download a pre-trained model from their official website. The AI Top utility supports many popular models as listed here. Additionally, prepare your own dataset for fine-tuning the model. Instructions for creating a dataset can be found in Chapter 3.3 of the AI Top Utility Manual. Here, I'm going to show you how to start fine-tuning using AI Top Utilities presets. Go to the Experiment tab. Enter your project name here, which will also be the name of your fine-tuned model. Then, add the file path to the pre-trained model you downloaded earlier. Choose where you want to save the fine-tuned model. Make sure your disk has enough space, as the file sizes can be large. By default, the checkpoint option is disabled for first-time users. Turn it on if you want to resume training from where you left off. Next, click on the box to select the path to the dataset file needed for training. The model will learn from this dataset. In the fine-tuning strategy, choose one of the following strategies according to your task objective. The fine-tuning strategy determines how the model learns from your dataset. Standard balances training time and accuracy, good for most tasks. Fast speed is faster, but might not learn everything in the dataset, suitable when precision isn't critical. High precision takes longer, but ensures thorough learning of all dataset knowledge, giving the most accurate results. Once you pick a strategy, all parameters will load automatically. If you want to train at specific times, like during off-peak hours for power-saving purposes, use the Schedule Tasks feature. Finally, go to the bottom right corner and click Run Experiment to start training. Once training starts, you can track progress at the top of the Dashboard tab. It shows how far along your training is and when it is expected to finish. Below that, you can see the usage of CPU, GPU, DRAM, and SSD in real time. This allows you to confirm if the resources are being used efficiently. Typically, VRAM or DRAM usage should remain stable during training. If you see the usage drop to 0, it could mean that there's not enough memory available. If this happens, the training will stop, and you might need to adjust the parameters. On the right side, there are 3 graphs to help you understand the task details. Training Configs is an overview where you can confirm the parameters and settings from the Experiment tab. Training Loss indicates how effectively the model is learning from the dataset. Ideally, the loss should decrease steadily and stay within a certain range, indicating good training progress. If training loss starts increasing, there may be issues with training. You might need to pause training to review the quality of the dataset or adjust parameters. Logs records every action during training. When working functionally, it provides real-time progress updates and related information. Any out-of-memory or other errors during training will also be recorded here. For advanced users, AI Top Utility offers complete flexibility with adjustments. On the Experiment tab, you can customize parameters based on fine-tuning strategy. Or, if necessary, you can click Clear to reset all parameters and enter new values. Keep in mind, though, that adjusting parameters directly affects the fine-tuned model. Let's explain how each parameter influences the fine-tuning. Here in the fine-tuning settings, you decide how to fine-tune the model, which affects how much the dataset influences the model. You can choose from these different methods depending on your needs. Full means that you completely replace the original model knowledge with the dataset. Freeze means that certain layers of the model remain unchanged to speed up training while maintaining the stability of the model. LoRa provides a flexible approach to integrating the model with new data. It retains most of the model knowledge and adjusts model weights selectively to meet new task objectives. QLoRa a derivative of LoRa, sacrifices some training precision to reduce memory requirements. This adjustment is particularly beneficial for large models exceeding 30 billion. In the training settings, you can adjust hyperparameters to control how the model behaves and performs during training. These settings directly influence how effective and efficient the fine-tuned model is for specific tasks. Backbone D-type determines how the dataset is processed, ranging from FP16, BF16, to FP32. Higher precision, like FP32, improves dataset accuracy but requires more memory. For example, FP32 uses twice as much memory as FP16. Learning rate controls how fast the model learns from the dataset, ranging from 0 to 1. A lower value increases accuracy but extends training time, while a higher value speeds up learning but might reduce accuracy. LR schedule type defines how the learning rate adjusts during training, with options like cosine and linear. Usually, the cosine type produces a more balanced outcome. Batch size determines how much data the model learns from each iteration, and it must be a power of 2. Large batch sizes speed up training, but will use more memory. Epochs indicates how many times the model learns from the entire dataset. For example, 1 epoch indicates that the model will learn from the dataset once. Save checkpoint strategy configures how often the training progress is automatically saved. None does not save any checkpoints. This strategy saves space, but would require a restart if interrupted. Steps will save checkpoints based on step intervals. This is ideal for a large dataset. Epochs will save checkpoints after each complete dataset learning cycle, suitable for a smaller dataset. Flash attention. This feature accelerates training and reduces memory usage with NVIDIA GPUs, and partial support is available for AMD GPUs. In the tokenizer settings, max length sets the maximum length in words for both the input query and the fine-tuned model's response. It's best not to exceed the maximum length the model supports. For example, Llama 3 supports up to 8,000 tokens, roughly equivalent to 6,000 English words. Using a longer length increases training time and requires more memory. Hardware settings. Here, you can view all GPUs detected by AI Top Utility. GPUs are numbered based on their inserted PCIe slot. For example, GPU 0 is in the first slot closest to the CPU, and GPU 1 is in the second slot, and so on. Offloading memory strategy offers 6 combinations of VRAM, DRAM, and SSD integration as training memory expands. However, using SSDs for AI training can increase read and write demands, so it's recommended to use SSDs certified by the AI Top. Expand Config allows advanced users to add more training configurations for further customization. Refer to Section 3.4 in the AI Top Utility Manual for detailed instructions. This concludes our basic introduction to AI Top Utility. To learn more, please refer to the AI Top Utility Manual. See you next time.